Hello everyone and welcome to this introductory video on NLP. Today I will be talking about the natural language processing in financial machine learning language. So let's go with the introduction. NLP is a fascinating field that sits at the intersection of artificial intelligence and linguistics. Its goal is to help computers understand, interpret and generate human language in a way that is both meaningful and useful. So as you can see, there are so many core techniques in NLP, which is textual analysis, text mining, computation linguistics, and content analysis. So why NLP is important in finance? Because it has ability to analyze the large volumes of documents in the finance. There are some key applications of NLP in finance. First is investment insights, which analyzes the shifts in stock prices and economic trends. Second is news and sentiment analysis. It enables fundamental analysis and creates a more comprehensive market view. The third is automating repetitive tasks, which automates the processing of news, SEC reports, and internal documents. Now we have some NLP packages. In NLP, the Python is the top choice for the NLP because of its vast library support, and it makes NLP to implement efficiently. There are some main libraries in NLP. The first is NLTK, Natural Language Toolkit, which is known for the most famous and the best NLP library for the Python. The second is TextBlob. It is built on the top of the NLTK. It is ideal for the applications with basic performance requirements. The third is Spacey. It is designed for the speed and production readiness. It offers a streamlined pipeline focusing on high performance. Now we have NLP for theory and concepts. So let's start with an overview of the NLP pipeline. This pipeline consists of three main stages: pre-processing, feature representation, and inference. Each of these stages plays a crucial role in taking raw text, cleaning it up, converting it into a machine relatable format, and finally using it to make predictions. So let's dive into each stage and see how it contributes to the NLP process. Pre-processing is the first step in the NLP pipeline. In this step, we clean and organize the text so that it's ready for analysis. We start with tokenization, where the text is broken down into individual words or phrases. Then we remove stop words. These are common words like the or is that don't add much meaning. Next we have stemming and lemmatization, which reduce words to their base or root forms. For instance, running and runner could both be reduced to run. This helps simplify the data without losing the meaning. We also perform part of speech tagging, where each word is labeled as a noun, verb, adjective, etc. based on its function in the sentence. Finally, we apply named entity recognition or NER to identify specific entities like people's names, dates, and locations in the text. All of these steps helps to standardize and simplify the text, making it easier for algorithms to analyze. In the last, we have the feature representation. Once the text is pre-processed, we move on to feature representation. Here we transform the text into a numerical format that machine learning models can interpret. A simple method is the bag of words model, where we count the frequency of each word in a document, although this method doesn't account for word order. Another popular approach is TF-IDF, short for term frequency inverse document term frequency. This method assigns higher weights to unique words within a document and lower weights to common words across documents, helping us capture more meaningful patterns. Lastly, we have word embeddings, a more advanced technique that represents words in multi-dimensional space, allowing us to capture semantic relationships between words. With embeddings, words with similar meanings end up close to each other in this vector space, adding a layer of depth to our analysis. In the last, we have inference. Inference is the final step in the NLP pipeline, where we apply machine learning algorithms to make sense of the processed data and draw conclusions. This is the stage where the text data, now converted into structured features, is used to generate predictions or classifications. There are three main types of inferences in NLP. supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, this type of inference uses labeled data to train models on specific tasks. For instance, in sentiment analysis, the model is trained on text labeled as positive, negative, or neutral. Supervised learning is commonly used for tasks like classification, where we already have a known set of categories. So, as a supervised learning models, we have naive-Bayes classifier and artificial neural networks. Naive-Bayes classifier probabilistic model that uses Bayes theorem with strong independence assumptions. It commonly uses in text classification tasks like spam filtering and sentiment analysis. It is simple, fast, and effective for the high-dimensional text data. Artificial neural network. The sequential processing for tasks like language modeling and machine translation. It is useful. Then we have transformers also, which architecture that relies on self-attention mechanisms. Unsupervised learning. In this approach, we work with unlabeled data to find hidden patterns. For example, clustering can group similar documents together even if we don't know their exact categories. This is useful in applications like topic modeling, where we want to identify themes within a large text corpus. So as a model, you can see here latent semantic analysis, which uses the singular value decomposition on term document metrics to identify the patterns in word usage. As applications, we can use this to capture semantic similarity between documents and for content summarization and similarity based searches. The second is latent Dirichlet allocations. The purpose of this model is probabilistic topic model that represents each document as a distribution over topics and each topic as a distribution over the words. As an application, we can use it for topic modeling for document clustering, summarization, and information retrieval. The last is reinforcement learning. Though less common in NLP, reinforcement learning enables models to make sequential decisions, improving performance over time based on feedback. It's often applied in dynamic environments such as chatbots, where the model adapts its responses based on user interferences. By choosing the appropriate type of inference, NLP systems can extract insights, make classifications, and automate language model-based tasks. In summary, the NLP pipeline is a structured process that transforms messy raw text into actionable insights, from pre-processing to feature representation and finally to inference. Each step is crucial in helping machines understand and respond to human language. Thank you for joining me on this journey through the fundamentals of NLP.